Whether you're asking your phone for the weather or getting a little help drafting an email, odds are you're interacting with a large language model, or as we all call them, an LLM, pretty much every single day. They're this truly transformative technology, but how do they actually work? Well, let's pull back that curtain and find out together. Yeah, it really all boils down to this one huge question. How in the world did we teach a machine to understand and, generate text in a way that feels so human? That's the core mystery we're going to start unraveling right now. Okay, so before we dive into the really complex stuff, let's make sure we're all on the same page. First things first, what exactly is a large language model? So at its most basic level, an LLM is just a massive AI model that's built to understand and process text. But here's the really crucial part. It's not just about understanding human conversation. We're talking computer code, financial reports, scientific papers, basically any kind of text-based data you can throw at it. And that ability to go way beyond simple language is exactly what makes them so incredibly powerful. So how do you even build one of these things? Well, you start with two main ingredients, deep learning and reinforcement learning. But for years, progress was kind of slow. The real game changer, the secret sauce that just blew the doors off everything, was an invention from Google called the transformer architecture. This was the moment that truly unleashed the power of modern AI. Okay, so we know what they are, but what's actually going on under the hood? Let's take a look at the engine that really drives these models. And yup, it all comes back to that transformer architecture we just mentioned. Its secret weapon is this brilliant thing called an attention mechanism. Now, just think of it like a super smart highlighter. As the model reads a sentence, it's able to pay attention to and highlight the most important words to understand the real context. This was just a giant leap forward from the older models. You can really think of the whole process like a simple conversation. First, the model has to listen. It has to really figure out what you actually mean. That's NLU, or natural language understanding. And only after it understands can it come up with a smart reply. And that part is NLG, natural language generation. It's a really simple but incredibly powerful two-step dance. First listen, then talk. Okay, so that's all the theory, but where is this tech actually showing up in the real world? Well, it turns out it's already being used in some absolutely staggering ways, and in pretty much every industry you can imagine. I mean, just look at this. We're seeing them in cybersecurity, where they can analyze millions of lines of log data in an instant to spot an attack. Over in finance, they're sifting through mountains of market data to find patterns a human could easily miss. And get this, they're even becoming what we call AI agents, where you can just give them a complex goal and they'll figure out all the steps to achieve it all on their own. It's pretty wild. And this quote, wow, this really drives home the sheer scale of the shift we're talking about. Just think about that for a second. In only a few years, at least half of all software development could be done by LLMs. That's not just a small change. That's a massive, fundamental transformation of a critical global industry. Right, but building one of these giant foundational models from the ground up costs millions and takes an unbelievable amount of data. So how do you adapt them for a specific job without having to start all over again from scratch? Well, that is where the whole process of optimization comes into play. And this whole process really works in layers. You start with pre-training, which is like building that giant general-purpose brain. Then you move to transfer learning, where you take that brain and let it specialize. Kind of like sending it to medical school with a much smaller focused data set. And finally, there's fine-tuning, which is like that last step of on-the-job training, just tweaking the final parameters for a super specific business need. And that leads us to one of the absolute hottest concepts in AI right now, RAG, or Retrieval Augmented Generation. Honestly, this is the magic behind so many new AI startups. The idea is simple. You take a powerful general LLM, you feed it your own private data, and bam, suddenly it's an expert on your specific information, able to generate answers that no other model in the world can. But the optimization toolkit doesn't stop there. Developers also use other really key techniques. There's RLHF, that's reinforcement learning from human feedback, which is basically getting direct input from people to make the AI more helpful and safe. And they use specialized vector databases, which you can think of as super efficient libraries, purpose-built for storing all this complex AI knowledge. But of course, a technology this powerful and this disruptive doesn't come without some really serious debates and some pretty big challenges. So let's get into the critical conversations that are shaping the future of these models. A lot of the debate really boils down to two major concerns. First, you've got experts who worry that these super easy to use tools might actually discourage the deep, specialized AI research we still need for high stakes fields like medicine or finance. And second, and this is a big one, they create brand new security risks. I mean, if one of these models can be tricked or hacked, the consequences could be enormous. And because those risks are so real, we're actually seeing the birth of entirely new professions, things like AI security and AI red teaming. These are literally jobs where people are paid to try and break these models on purpose to find and fix the flaws before the bad guys have a chance to. Now, you might hear the terms MLOps and LLOps getting thrown around, and it can be a little confusing. So what's the difference? Well, let's stick with the car analogy. MLOps is like being a full-on car manufacturer, designing and building the entire car from scratch. It's a massive, expensive undertaking. LLOps, on the other hand, is more like being a custom auto mechanic. You take a powerful, pre-built engine, say an open source model like Llama, and you just focus on dropping it in, integrating it, and tuning it for a specific purpose. It's way, way more accessible. So when you step back and look at the big picture, there's just no denying the conclusion here. LLMs, they're not just a passing trend. They are absolutely at the forefront of a major global transformation. They are poised to fundamentally change countless work processes in pretty much every field imaginable. And all of this leaves us with one final big question. Because this massive transformation, it's not a what if anymore. It's happening right now. So the real question for all of us is this. As this technology gets faster and smarter by the day, how is it going to reshape not just our tools, but the very way we all work, think, and create?